take 3. And we're just talking, people were seeing my video recently about earth bonding, and some people said, well, don't really understand it. So let's just start with the very basics. It's all about RCDs, residual current devices, earth leakage circuit breaker. The earth leakage circuit breaker is a device that prevents you from getting electrocuted. That's it. All consumer units have one. They may have one, they may have 2, some of them have multiple on every channel, depending on whereabout you are in the world. But the purpose of it is, if you touch a live wire, then click, it trips, and that's it. If you also get a neutral to ground, it can also trip, which can be a nuisance tripping, where you've often got a neutral fault. It can also trip an RCD. How does an RCD work? So basically, an RCD is a device that your power goes in. So I'll draw the RCD as a box, simple like that, okay? There used to be a Wheatstone bridge, now they're they're very simple now with this sort of microchips, most of them using these little Fairchild chips or whatever. So basically on the bridge here, I have my live, my neutral in, and I have my live and my neutral out. And so basically, the switch device here measures the incoming current here, and if my income current is 1.101 amps, and my outcoming should measure the same. So the circuit 1.101 amps. I'll just use this for argument's sake. Yeah. And the power going in, so the power going here to the device here would be the same. 1.101, 1.101. Everything balances. Everything balances. What goes in is what comes out. Now, if I was to touch a live wire here, so this is my RCD, or we used to call it ELCB, earth leakage circuit breaker, or a residual current device. If I was to touch here, so I put my fingers on here, and rather than using it, I will use the symbol as a resistor, and that's just me, okay? So because I'm at ground, and then this is me, okay, touching this, the resistance of my body, and I touch it here. That means the 1.1 will go in, but some of the energy would come down this way and some of it would go that way, and therefore what would come back on the other cable may only be, say, 900 milliamp, okay, 0.9 of an amp. That's an imbalance, and that will cause the RCD to trip, and that imbalances. If I was to do the same with the neutral wire, the same thing can happen. It causes an imbalance in the power. Now, the RCDs are a wonderful device. They prevent a lot of people from getting electrocuted. You know, in our office now, if I was to put my fingers in the live socket, click, the thing will switch itself off, and it'll prevent me from dying. And that's the idea of it. You get a little shock and it'll click, and it's not going to kill you. And that's the purpose of these devices. They're fairly sensitive. They measure like 30 milliamps, a slight difference in click. And sometimes people say they're a nuisance, the electric kettle trips it, or the toaster trips it, or the iron trip it, because there is a fault condition happening internally, maybe caused in an iron, maybe caused to water or whatever. There's a fault condition. So that's what these are used for. And what I was explaining is the RCD will feed the inverter, because the inverter is just like a normal piece of kit on the grid. It should be fed through an RCD. Now, I know in some countries they don't use RCDs, they don't exist, but generally they should be used. Use RCD in conjunction with an MCB, main circuit breaker. Circuit breaker is different. Circuit breaker is for overload. The RCD or the ELCB is for earth fault. 2 different devices. We've also got a new device which is coming up, which is an arc sensing device, which is something that's coming available very soon. So you may end up with 3 devices on it: MCB, RCD, and an arc sensing device. So there's 3, but at the moment we're just focusing on the RCD. So the reason the power goes into an inverter and then coming out of the inverter, we also put an RCD. Now, when it comes out of the inverter, the RCD will not function. It can't function. So the problem is, when the power comes out of an inverter, and this is my inverter here, okay, I haven't got a live and neutral. I basically got 2 outputs, and I can call it L1 and L2. They come out, I put them into an RCD here, RCD, and here is my, and I'll call one of them live and one of them neutral, and this is my load. But in fact, these are balanced. And these are basically like an isolated mains. If I'm to touch here, if I'm to touch on, I'll just use the live wire, and I put the resistance, which is me, it's my smiley face, and there's the ground here. I'm touching the live here. This cannot trip, because this device is measuring what goes in and what goes in here, what comes out, what goes in, what goes out. Because when I touch the ground here, these aren't referenced to this. This has to have a power flow. So if I was to touch here, the energy can't flow here. The only way this energy can flow through here is if on one of them, I use a relay and I put it to ground. And by putting it to ground, and I call it the neutral, and I call it the live, and by putting the cable which I call neutral to ground, then it can allow a flow. Because if I to touch here, some of the power will, so the energy coming in, so I put 1 amp here, so it's 1 amp here, but some of the energy, maybe 50 milliamp, will flow through here, it will flow through the ground, and it'll come back here. So some of it will flow this way, and some of it will flow back this way. And there's going to be an imbalance and therefore the RCD will work. And it only can happen by putting this bonding in here. This bonding can't stay permanently here, because if this stays permanently here, what I spoke about is the upstream RCD will trip. So the upstream RCD will trip. And that's why we have to do this as a temporary, and we put this as a relay. And we can only close this relay when the inverter is in islanding mode. It's not connected to the AC. It might be connected to the AC, but still operating in islanding mode. Once that connection makes to the AC and those internal relays close in the inverter, then this bond must be removed. Otherwise, it will trip the upstream RCD. I hope that explains a little bit. That's my third take, and I hope CJ, do you follow a little bit more?
Yes, 100%.
Right, thank you.